We'll proceed in cross Jacobian for calculation of sphere surface area. Okay, so much awaited cross Jacobian to calculate the surface area of a sphere. Okay, so we are in a phase to calculate the surface area, surface area of a sphere. So, what is the surface area of a sphere? Okay, what is a sphere? I have one sphere. Okay, I have one sphere. If this is the sphere, then what is the surface area of the sphere from the partial from the cross Jacobian point of view? So, if I take cross Jacobian into the consideration, then what is the volume, not volume, surface area of this sphere through cross Jacobian? There are three kind of Jacobian that we have seen. One is full Jacobian, that is anyway everyone knows, and one is partial Jacobian and full Jacobian, partial Jacobian, and cross Jacobian. Three kind of Jacobian: full, partial, and cross Jacobian. Through cross Jacobian, can we calculate surface area of a sphere? If people are not willing to know these many Jacobians are there, at least they can find a different way in finding the surface area of a sphere. What can be a different way in finding the surface area of a sphere? So that is the question mark. What is the different way possible to calculate the surface area of a sphere? So now consider xy plane. If this is xy plane, this is xy plane. This is a plane, and this is xy plane. This is x-axis, this is y-axis, and this is z-axis. X-axis, y-axis, and z-axis. Three axes are there. And now we have xy plane. This is xy plane. One is x-axis and one is y-axis. This is z-axis. Now I have a sphere on top of xy plane. What is the surface area of the sphere? Now consider this sphere is centered at the origin. The center of this sphere coincide with the origin. This is the origin, blue color. Then this center coincides with the origin. If that is the scenario, that center of this sphere coincide with this origin, then what is the surface area of the sphere? Okay, that is the real scenario. I have kept the sphere coincided at the origin. Center sphere is centered at the origin. Now, if I consider sphere is, that is the actual case we will take. Now, this is the sphere center or the origin, or this is a sphere. If I take any point P on the sphere, then what is the coordinate of P? X, comma y, comma z. Where x, comma y, if this is point P, then P, this point, if I go and map on xy plane, then it will come somewhere here. This point is x, comma y, and function over x, comma y. If I pass this x, comma y through a function, it will give me one altitude, one numeric value, that is z. So this point is x, comma y, comma z. If that is the case, then from center, if I draw a position vector, then it is xi plus yj plus zk. Position vector P. P on top of it arrow mark. Position vector P is xi plus yj plus zk. If that is the case, then what is dp by dx? Position vector by dx. I'm not talking about dy by dz by dx. dz by dx means if I have a sphere and this is x-axis and this is z-axis, this is xz plane. Now, if a at any point, any point, if I proceed x-axis unit distance, how much z would vary? If this is a point, if this is a point called x comma y comma z, and if I go along x-axis a unit distance or delta distance x plus delta x, then it will map to another point P2, that is x plus delta x comma y plus z is new now, that is f. Z is fxy, now it is fx plus delta xy. Z is dependent upon x. dz by dx, if I had z value at point x, now if I go x plus delta x, I have new z, that is z2. What is z2 minus z1 by delta x? If I change x delta x, how much z changes? So dz by dx, if there is a unit change in x, how much unit change it brings in z? That typically happens on xz plane, dz by dy. Anyway, we are talking about dp by dx. If there is a position vector p, okay, I believe I have demonstrated this many times. So if this is a position vector p where this point is x comma y comma z, now if I go on x-axis, this is x. If I take x plus delta x, then this p would move here. Okay, dp by dx. If I move unit distance along x-axis, how much p would change? Now p is a vector. How much it change? That depend upon new x point, y and then z. Z depend upon x with the function. So z will change, x will change. In xz, p dp by dx. P is xi plus yj plus zk. P is xi plus yj plus zk. dp by dx is I plus dz by dx k. I k means dp by dx is a vector. dp by dx is a vector that is in I z, x z plane. dp by dx. dp by dy is a vector in j k plane, j plus dz by dy k. If that is the case, then dp by dx I can simply take any vector in xz plane, that is a vector. dp by dy I can take any vector in yz plane, b vector, a and b. Now if this is a and b, if this is a in xz, I think too many things I am carrying. Okay, in xz plane, if this is a vector, and in yz, this is yz plane, this is xz plane. In yz plane, I take b vector, a vector, b vector. Now if that is the scenario, then this is the a vector, this is b vector. There is a ab plane, and a cross b is the area between a and b, that is a parallelogram. Okay, so if I have a vector a, if I have a vector b, then what is the area? Then I have to take another vector like this parallel to a, another b, then parallel to b. It makes a parallelogram. A cross b is the area of the parallelogram between a and b. And then what is the unit vector? That is the perpendicular to this plane. If this is the plane, then net cross is the perpendicular to this plane. That is the net vector direction. So direction is a cross b. Magnitude is a cross b. Whatever comes, calculate the magnitude, and then the direction is perpendicular to the AB surface. Now we have dp by dx, dp by dy. That is I plus dz by dx k, j plus dz by dy k. Now dp by dx cross dp by dy gives the, if this is the sphere, if this is the sphere, if this is the sphere and this is point P, this is point P, then dp by dx is in xz plane, dp by dy in yz plane. dp by dx and cross dp by dy gives the area at any moment. area area at that moment, it is also called area vector. But it is since dp by dx, dp by dy, it's not p, it's by x. This is called velocity area vector. So at what is the area vector at any point? It will be controlled by the algebra. So position vector P is xi plus yj plus zk. dp by dx is I plus dz by dxk. dp by dy is j plus dz by dyk. dp by dx or dp by dy is nothing but whatever it will, if I calculate the cross product, if I calculate the cross product, then 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 it is called velocity area vector. If I calculate the magnitude, then it will give me the area by xy plane, because the dp by dx, if it was only p, then it will give the area. But we want the xz vector in vector in xz plane, vector in yz plane, dp by dx, dp by dy, then it will give d surface area. If I calculate this cross product magnitude, it will give d surface area by dxy plane. dp by dx cross dp by dy. If dp by dx is a vector A, dp by dy is vector B, then A cross B would give A cross B. Okay, dp by dx is vector A and dp by dy is vector B, then A cross B is the area between vector A and vector B. If that is the scenario, vector A and vector B, area between vector A and B, that area is the, at any point here, that area is the surface area. But it is momentary, it is instantaneous at that point. Every point things would change as per the control by the algebra, that is dz by dx, dz by dy. Anyway, this is called dp by dx cross dp by dy is called d surface area by dxy plane. Okay, if I calculate the magnitude, it will come as d surface area by dxy plane, dp by dx cross dp by dy. If I want surface area, then I have to multiply with the dxy plane, d surface area by dxy plane, dxy plane. That dxy is dx dy I can take. This d surface area by dxy is the velocity surface area. So now if I have I plus dz by dx k cross j plus dz by dy k, then it will come as minus dz by dxi minus dz by dy j plus k. This is velocity area vector. If I calculate magnitude, dz by dx whole square plus dz by dy whole square plus 1 square root dx dy, this will give the surface area of a sphere. But this dz by dx, z for the sphere is square root of a square minus x square minus y square. X square plus y square plus z square equal to a. Z is the square root of a square minus x square minus y square. dz by dx minus x by square root of a square minus x square minus y square. dz by dx whole square. X square by square root x square by a square minus x square minus y square plus y square by x square a square minus x square minus y square plus 1 square root. Okay, if that is the case, then it will settle down to a by square root of a square minus x square minus y square dx dy. This is cumbersome. This is very difficult to integrate. That's why we are going with the cross Jacobian. So cross Jacobian is nothing but we will do something that is in another coordinate system. So xy, right now we have xy. So if this is a sphere, so better we will take in a spherical coordinate system. So in a spherical coordinate system, there are three independent components. One is theta, one is r, and one is phi. Means this sphere, if I take the center of the sphere, then the sphere is at maximum radius. If I go up, then on top there is no radius. So at the center, if I cut it, then radius is a, that is the sphere radius. If at height z, height z from the center height z, if I cut it, then radius will be small. Again circle small, the radius is r. Or other way, if this is the if I cut at the equatorial plane, means if sphere is centered at the origin, and if I take xy plane at the center, then from the origin, if this is the flat and this is radius a of the sphere 2 pi degree, it will move. Now if this radius, if I move in vertical direction, then it will go till top. If I take any direction like this, this is radius of the sphere. Okay, and this is the momentary height. So you can say that a sphere is cut at this level and radius is r. Okay, whereas at this point radius is a. Okay, so if this is radius a. If I move like this, then here if I cut, then there is small radius a, radius r. Okay, from vertical it makes angle phi. This phi, if this phi is 90 degree, then we reach the xy plane. If this phi is 0 degree, this is exact vertical. If this phi is some angle phi, then there is another cross section at height z, that is r. This r would fall on xy plane also. This is a small r, and if it goes like xy, this is a. R is here at angle phi. This r I can rotate. This r I can rotate 2 pi theta. This angle is called theta angle, whereas this angle from the vertical is called phi angle. Now, if this goes on xy plane, and then it makes angle theta. R cos theta is x at any moment. R sin theta is y any moment. And if this is angle phi, then a, I'm talking about only surface, not the volume. So this this is the radius of the sphere. When the sphere is centered at the origin, then this is xy plane. At xy plane means if this sphere is centered at the origin, then at the middle xy plane goes. Top hemisphere is above the xy plane and bottom hemisphere is the below xy plane. Now this is centered at the origin. It will go inside and it will be centered at the origin. If that is the case, if it is centered at the origin, if that is the case, then I can cut this the half. If I cut, then this is a maximum radius a. Now at height z, if I cut, there is a small radius r. Okay, so the at if this is the xy, if this is the xy plane, if this is the xy plane, then this radius, if I go up and then cut here, then angle from the vertical is phi. This point can map on xy plane. This can rotate like this in theta fashion, and at any moment it can map on xy plane. There, if I take theta, then it is, this is now, if this is a, then it would map, this radius is r, this bigger radius is a. Now this r, if this is mapped, same r would be mapped on the xy plane. So this r, if this angle is phi, then a sine phi is the r, or someone can calculate this fashion also. If this angle is phi, so I'm sorry, if okay, so it goes like, from this is vertical, from vertical it goes like this. This angle is phi and this is r, then r is a sine phi, or it falls on xy plane, then again a sine phi. So the x is a sine phi cos theta I, y is a sine phi sin theta j, and z is a cos phi. Okay, so we are talking only about the surface. Now x is r cos theta I, x is a cos a sin phi cos theta I, y is a sin phi sin theta j, and z is a cos phi. Okay, so z is a cos phi. Now, what about calculating the surface area? So, if I try to calculate the surface area, then area has two sides, volume has three sides. So, if area has two sides, if area has two sides, if I talk about any area here, it has two sides. What are the two sides? There are three independent components in a spherical coordinate system. One independent component is r, one is theta, and one is phi. R is the radius. Here radius is fixed because we are talking about surface area. All along the surface, radius is fixed. Okay, that is the A. But if I take any small area here on the surface, then there are two things that is variable. Because if I take a surface area here on the xy plane, on top, here, two components will keep varying. One is phi, because if I take surface area here, then phi is 0. If I take surface area here on xy plane, then phi is 90 degree. If I take surface area in between, phi can be 45 degree, whatever. Phi is varying. Now, if I rotate like this and take surface area here on back side, then theta would vary. So phi and theta are variable on the surface as far as surface area is concerned. So now, neatly I can say now dp by dx cross dp by dy, d surface area by dxy plane into dxy plane. That was the equation for calculating the surface area. Now dxy plane can be written as dxy by d theta phi into d theta phi, dp by dx cross dp by dy into dxy by d theta phi into d theta phi. D theta by d theta phi can cut down. I have just added it. Now dp by dx cross dp by dy is d surface area by dxy plane. dxy plane cut down. Now d surface area by d theta phi into d theta phi. D theta phi is d theta d phi. D surface area by d theta phi is d surface area by d theta phi is now dp by d theta cross dp by d phi. This is cross Jacobian. This is our invention. So if I have xy plane, on top of it I have surface like this, that is point P, position vector P. If this P is dependent upon xy plane, but xy plane is dependent upon now theta phi plane. So this is xy plane dependent upon theta phi plane, whereas P position vector is dependent upon xy plane. Or in other fashion, we can say this is xy plane, this is the sphere. This is point P, position vector P. Now P is dependent upon xy plane. Xy plane is dependent upon theta phi plane. Now xy plane we are kicking out. Now the surface is directly dependent upon theta phi plane. This is cross Jacobian. This is gone. So the surface is directly dependent upon theta phi plane. Surface is directly dependent upon theta phi plane. Xy gone. dp by d surface area by d theta phi into d theta phi. Xy cut down. So dp by d theta cross dp by d phi, that is d surface area by d theta phi into d theta phi. If that is the scenario, then dp by d theta plus d cross dp by d phi, what it is? D theta d phi, I can understand integration. Now position vector P is xi plus yj plus zk. So now x is a sin phi cos theta I plus a sin phi sin theta j plus a cos phi k by d theta cross d of a sin phi cos theta I plus a sin phi sin theta j plus a cos phi k by d phi. First, with theta, if I do the derivation, then it will become a sin phi minus sin theta I plus a sin phi cos theta j plus nothing. A cos phi will go away. Cross product with differentiation with d phi. Now it is a cos phi cos theta I plus a cos phi sine theta j plus a minus sine phi k. Okay, now cross product of these two. Cross product of a sine phi minus sine theta I plus a sine phi cos theta j. Cross product with a cos phi cos theta I plus a cos phi sin theta j plus a minus sin phi k. Cross product. We calculated it. Okay, we took time to calculate it, and at the end it comes whatever it comes. Okay, cross product whatever it comes. So whatever it comes, then we have to calculate the cross product. Once cross product comes, then we have to take the magnitude of it. That is the d surface area by dxy plane. If you see the beginning description what we gave, d surface area by dxy plane, I have to take magnitude of this, then dx dy. So we did the cross product offline and we calculated the magnitude of it. Means it came as some I, some k, j, some k. Then ith component square plus jth component square plus kth component square root. Then it came as a square sine phi. At the end, it came as a square sine phi. A square sine phi d theta d phi. Now integration over a circular region. That is another bottleneck in cross Jacobian. Now, if I have a sphere, anywhere sphere, if sphere is centered at the origin, then if I take the intersection on xy plane, it will be a circle. It will be a circle. So integration, so it will be typically a circle. So integration will be, limit will be a circular region where x is minus a to a, y is minus square root of a minus x square to plus square root of a square minus x square minus square root of a minus x square to plus square root of a minus x square minus a to plus a. Okay, this is the limit. This circular region, now it is in x and y. Now we have to transform into theta and phi. This is amazing, exemplary. We are not talking about theta. Theta r is the polar coordinate system. Theta r z is the cylindrical coordinate system. Theta r phi is the spherical coordinate system. What about theta phi? It does not belong to any coordinate system. We are calculating surface area of a sphere with the new coordinate system theta phi that do not belong to any coordinate system. Now I cannot take limit the way we want. If it was a polar coordinate theta r, theta blindly I could have taken since it is a circle. Theta is 0 to 2 pi and r is 0 to a. Simple. Now theta phi, can someone convert it? Now we have x and y that I have to convert to theta and phi. Mind blowing, very difficult. Now y, y is minus to plus. Let's take upper half of the circle. So if we are calculating the surface area we are calculating in x and y. So top hemisphere we are calculating of the surface area. This is x and y. We will see it, but whatever the integration limit is a circle, we will take upper half of the circle. Y is 0 to square root of a square minus x square. Ax is minus a to a. If that is the case, then if that is the case, now y equal to a, y equal to 0, y equal to a sine phi sine theta, y equal to a sine phi sine theta. We are talking about phi. So if that is the case, then y is 0, then sine phi is 0, phi is 0. From 0 phi would start now. Now here y is square root of a square minus y. Now upper limit is y equal to square root of a square minus x square. Y square plus x square equal to a square. Y square is a square sine square phi sine square theta plus y square sine square phi cos square theta equal to a square. A square gone. Now sine square phi and sine square theta plus cos square equal to sine square phi equal to 1, phi equal to 90 degree. So 0 to 90 degree phi would go. Someone can think about minus pi by 2 to pi by 2. If original was minus a square root of a square minus x square to square root of a square minus x square minus pi by 2 to pi by 2, whose circle would go. Okay, and x is minus a to a. Let's settle down this. Now we have a square. A square I can keep outside. Sine phi d phi, that is minus cos phi. Cos phi is the integration. Now minus pi by 2 to pi by 2 minus pi by 2 to pi. It will resolve in 0. So there is problem. So we'll stick to 0 to pi by 2. 0 to pi by 2. This is our consideration, that if it is pi, let's go with the 0 to pi by 2 one. 0 to pi by 2, it will settle down in 1. Pi by 2 cos is 0, 0 is 1, lower limit minus minus would cut down, it will come as 1. So don't go with the estimation. That's why I say mathematics is nothing belong to approximation, estimation. If we did from 0, y is 0 to square root of a square minus x square, let's go with it. Otherwise, see what we are getting. So 0 to pi by 2 is the integration is 1. So phi component is gone. Now theta, if I integrate, it becomes theta. D theta, if we integrate, it becomes theta. Now x is minus a to a. Let's for x minus a to a, let's go for the x as 0 to a. Again another quadrant. Here we are taking the top quadrant. Now x we are taking 0 to a. So only first quadrant I have to multiply by 4. 0 to a. If it is 0 to a, x is 0 to a. When x is 0, then theta is 0. When x is 0, then theta x equal to a sine phi, sine phi cos theta. Or rather, I believe that the better would be that x equal to a x equal to a sine phi cos theta, y equal to a sine phi sine theta, y by x equal to sine theta by cos tan theta. So a and phi gone. So theta equal to tan inverse y by x. If x is 0, y is also 0. So whatever, y by 0, infinite, so that is pi by 2. And when x is a, then at that moment y is 0. So 0 by a means 0. That is tan inverse 0 means 0. Pi by 2 to 0. Pi by 2 to 0. So now theta is pi by 2 to 0. If I leave this negative right now, then pi by 2 to 0, then theta integration is pi by 2. So pi by 2 a square is the surface area of the sphere. Pi by 2 into a square. Now we have taken only one quadrant. I have to multiply it by 4. So pi by 2 into a square into 4. 2 pi a square is the surface area of the top hemisphere, because sphere is centered at the origin. We are taking only top hemisphere because this is what we started. Now if I multiply by 2, then it becomes 4 pi a square. So 4 pi a square is the surface area of a sphere through cross Jacobian. This is mind blowing. Someone can try with pen and paper. And the biggest challenge is dp by d theta cross dp by d phi. That someone has to, and magnitude, someone has to come at a square sine phi. Then person has to calculate the limit, that is for first quadrant. If it is circle, 4 quadrants are there. For first quadrant, y is 0 to, then y is 0 to pi by 2, and theta is pi by 2 or 0 to pi by 2 again. So someone can try and calculate the surface area of a sphere through cross Jacobian. So we will see other thrilling things also. So that we'll see. Please support us. This is a very new thing. We are talking about cross Jacobian calculation of the surface area. Our number is +91, that is India country code 94831606110. plus 919483160610 plus 91 is the India country code. So we will see back with the kind of another example in the Jacobian. This is the means we are just doing case study in Jacobian so that anyone would be thorough in calculating the Jacobian. So here, if I have a limit, I have integrand and differential. Typically, differential we change it to another differential as per the method of substitution in integral calculus, and we attach one Jacobian. So here Jacobian considered can be considered as dp by d theta cross dp by d phi magnitude. So that more example that we will see.